Yeah, it was really nice. No, Maggie knows.
Yeah, it is. It is.
Monday, it's at like, it's 10 o'clock. This should be there. You should be able to read right.
I'm only periods. I'm only here 4 periods. We're something else. I only have 6 periods. Right. For him, it's like, does it makes sense for him to come. So, yeah, you know. No.
You play against Brock Bauer?
What do you want to think? Yeah, it makes sense for him. He has 2 periods here. That's it. So it's like Mr. J.
Oh, yeah.
Mr. J, Mr. Yang. Yeah.
So I can also do
This change is happy to see it.
Dan, you want to finish the
We should know.
5 points. Okay.
We should.
Yeah. Brock Bauer scored 43.
What happened?
Brock Bauer scored 43.
Oh, I didn't know that.
Quiz. I literally, the only reason I wanted to get a shit award all seniors.
My team is terrible. One person got 15 points. Brock Bauer scored 48 points. My team, Brock Bauer.
No, I feel like.
My team didn't even do bad, but I just got 150 dropped me by the worst team in the league.
Yeah, no, that makes sense, right?
Hey, the Dodgers did not won.
That's the worst team in the league.
Dude,
Dodgers did not won that thing. Dude, both of this kids running is great. My RB2s, but both the RB1s were out this morning.
No, he is
So a good series. No, not Brown. The non-guy just gets 200 yards.
Oh, I said, what happened?
How much of what?
My team's back. I'm looking good now. I'm gonna win.
Dude, you just lost.
I just like 5 games. I just got from good. Bro, stop from the back. Oh, he likes me, really? Yes. That's why I scored Yuppie the second time. Oh. Wait, how long's he out for?
I don't know.
My team is actually atrocious without him.
Yeah, I don't think next week. Yeah, I don't have, it's all one year.
I have like 4 receiver one.
What?
Yeah, make some trade. No one will trade. My league, if you trade, you're guaranteed getting up to a ripped off center.
It was like after a lot.
You don't know. I don't have anything. I only have a person second here, but I don't know what.
I want my son.
Okay, if you can turn to page 13, this is the last topic before we look at, before we start reviewing for our quiz.
Yeah.
Wednesday. Wednesday. Yeah, I'm not this. Mr. Yang, Wednesdays.
Next week, next. Next Tuesday.
Okay.
Next Tuesday.
Oh, I did this one. Yes.
So, we're almost done with, or sorry, Wednesday, we still have another topic, but this is very similar. So, we'll cover e to the x today. We'll talk about another variation of exponential function on Wednesday, but I think we largely start review on Wednesday. We'll have Thursday, Friday, and Monday as well to review. And then our quiz will be next Tuesday. All right, so page 13, we're going to just work on the derivative of exponential function e to the u. E to the x and natural log are inverses of each other. And just as a reminder, the derivative for natural log of u is u prime over u. And today, we're going to talk about the derivative of e to the u, which is, the nice thing is that it's basically the function itself is the derivative. But there's a little bit of chain rule here. If the exponent is more than an x, then we have to do times u prime to take care of chain rule. So I'm going to kind of pick out problems that may be a little bit different from your notes. So you can just, yeah, if it's a different problem than the one that you see, just cross it out and just copy the one that I have. So let's start with the easiest function here, which is e to the x. So the derivative for e to the x is just itself times the exponent's derivative. So y prime is simply e to the x times what? Sorry, so these, you can cross out the ones that are on there on the notes, and just because I want to start a little bit easier rather than jump into the more involved ones. So yeah, if it doesn't match the problem that you see, just cross it out and do the one that I have. So e to the x times what? 1, yeah. X's derivative is 1. So if it's just x, then your derivative will look exactly like your original function. So this is an easy rule to memorize because it's just the function itself. Let's do another one that is a little bit more involved, but still relatively easy. If my function is e to the 3x, and I know I'm going to follow my rule of e to the u, my derivative is just what? Yeah, e to the 3x times 3. Yeah. So basically, the original function is always going to show up in your derivative for exponential function. Okay, let's do something a little bit more involved. Y is equal to x squared e to the 5x. Obviously, we have to involve power rule, and then we have to involve e to the u. But is there something else that we have to make sure we include? Yeah, product rule, right? You can't just say x 2x times e to the 5x times 5. We have to go through a full product rule to build that derivative. Okay, so. All right, so try this one. See if you can build out each part's derivative. Get to your y prime. Okay, f prime g plus f g prime. X squared becomes 2x. G stays as e to the 5x. F is x squared, and g prime is e to the 5x times 5.
These bottom examples, are we have them also?
I'm sorry.
These bottom ones?
Let me see. Uh, I think we may skip 7 and 8.
Okay.
The next one is number 4, but it's really number 6. You can put it anywhere. But I think this is the last problem that we're going to do on this page. So x e to the y minus 10x plus 3y equals 0. Okay, we're asked to find the derivative. What do you notice here? What's involved? Okay, implicit. Yeah, anytime you see y, a variable mixed into your equation, you know there's implicit. Okay, good. So we got to keep track of our dy dx's. What else? Good, product rule. Yeah, x times e to the y. We got to go through the whole product rule there. Good. How many dy dx's do we expect? 2. Yeah, there's 2 y variables, so you're going to be expecting 2 dy dx's. All right, so try that. Let's see if we can start off with product rule. You know that x and e to the y is going to have to, we have to involve product rule to get through that derivative. And the rest should be power rule, but then we're also keeping track of our dy dx's when they need to show up. Right, so x and e to the y, we're going to have to build out product rule for that. X becomes 1, and g is e to the y. F goes back to x, g prime is e to the u times u prime. So e to the u is the original function times the exponent's derivative. Y's derivative is 1, but we're asking for y's, since we're asking for y's derivative, we need to attach a dy dx. We keep going. 10x becomes 10. 3y becomes 3. We're asking for dy dx. Sorry, we're asking for y's derivative, so dy dx shows up. So just like what we expected, we're hoping for 2 dy dx's, and that's a way to make sure that we're keeping track of all of our variables. Okay, any questions so far? All right, so we're done with the calculus. Now the remaining steps is just trying to add and subtract, divide in a way where eventually you can get your dy dx variables together on the same side and factor it out. So I've underlined the terms that I'm going to keep on the left side. And then the non-dy dx terms, I'm just going to move, add or subtract to the other side of the equation. I can factor the dy dx out and solve for dy dx. And so no matter how complicated your derivative process ends up being, ultimately it's still getting to the same point in terms of what we're dealing with here. We're just creating some slope formula that's going to describe the slope of some original graph. So if you put enough information into your derivative, in return you get a number, and that number is describing the slope of a point on the original graph. Yes.
Right. We did the natural log. Like it was full type stuff. If we replace the y's with the original.
Yeah, we only do that if we go through something called log differentiation. And this is like this, if I have, if I start off with non-log equation and I'm forcing the left and right side to be log form, then there's going to be implicit here. And then when you solve for y, solve for dy dx, the y will get replaced with x. So we only do that replacement with y with the original function if it's under log differentiation. Yeah. Otherwise, we're not going to be expected to do that because this one is starting off. It's not going to start off as an equation, so the derivative will need y's in it in the derivative. But if you start off with a function, then the idea is that your y is only a temporary variable, and we should be able to bring back just in terms of x. Sorry, we have one more before we move on. We're going to do this number 5 here on page 13. So find the equation of the tangent line at x equals 1 for our function. So this is a two-step process. Well, we need to gather two sets of information. We have to find the order pair, which I think this one does give you. But if the y value wasn't given to you, you will plug 1 into the original function to get your y value. And then to get our tangent line, we have to get our slope. But to get to our slope, we have to get to our derivative. To get to our derivative, we have to go through what to get to the derivative. Cool. Yeah. So build out product rule f prime g plus f g prime. What's e to the negative x's derivative?
Negative x e to the power of negative x.
Say it again.
Negative x e to the power of negative x.
Close.
E
It's e to negative x times negative 1. Yeah, so it's the derivative of the exponent. Okay, but you have the right idea. So e to the negative x times negative 1, that's my f prime. My g function I can keep, f function I can keep, and then g prime, natural log of x. The more recent rule that we learned, natural log is u prime over u. So in this case, just 1 over x. I'm just going to do a little bit of cleanup before I plug in the 1 to get the slope. Okay, plug 1 in, get the slope. That natural log of 1 is 0, so that's going to wipe out that first term. My slope it's just going to remain as 1 over e. So I have my slope, I have my ordered pair, put it all together, point slope form. Yes.
When you multiply e to the negative x by 1 over x, why does the e not stay in the when you bring the negative x back?
Right. So, so here's the rule. The rule is, let's say I had 2 to the negative 3, right? This would be the same thing as 1 over 2 cubed. Right. And so if I have e to the negative x, it's the same thing as 1 over e to the x. Yeah. So if I get rid of that negative, it's going to force my base and my exponent to come down to the other side.
Oh, isn't this e's a number?
E's a number. Yeah, e, that's right. Yeah, it's, well, even if it was a variable, it would still be the same thing. X to the negative x would still be 1 over x to the x. But yeah, e is E is a number. All right, good. Any other questions here?
Can you re-explain, like, when you find one prime of one,
Mhm.
how we get it down to 1/e?
Right, so there's a property here, natural log of 1 is equal to 0. So that's gonna wipe this whole thing out. So I'm just left with 1/e.
Got it. Thank you.
Hey, page 15. All right, so start with 33. A lot of this you can just do in one step. Some other problems may require a bit more. But go ahead and start 33. I'll work through the problem same time that you guys try it, so you guys can check your answer as you guys work through. Okay, any questions with the first four? All right, the next four, hopefully we can see the need for product rule for each of them. They're all involving multiplication of different functions. All right, any questions 39 to 42? All right, look at the setup for 43. We have to use what rule there? Integral. Yeah, there's clearly an outside and inside portion. We're gonna take turns building out each part.
Wait, how'd you get the -1?
Oh, right here.
Yeah.
So that e to the negative t is its own little chain rule there. E to the u becomes e to the u times u prime. (44) is also e to the u times u prime, but I'm rewriting that exponent so that I don't have to go through quotient rule within the u prime. If I can just bring that t squared up, then it feels a little bit cleaner with power rule there. All right, 45. Remember, we can't distribute natural log through. We have to jump directly into our rule. So for natural log, it's just u prime over u, right? All right, 46 is also a natural log expression, but this is a pretty large u value. What can we do before we do our derivative step? What's available to us? Quotient property, right? Expand, okay. So now u prime over u for our natural log derivative. Okay, next page. Okay, does anybody still need to look at 45 or 46? So 47, we could go through quotient rule, but there's only a constant above, so I prefer to just rewrite it. And that way, all I need is chain rule. I find that to be a little cleaner than, it's not wrong if you went through quotient rule, but I would prefer to find the derivative at this stage than this stage. Outsized derivative. Times the incised derivative. Uh, 48 is just a single constant in the denominator. I can just split this up into fractions here. And that way, the 2 can just be a coefficient in front. And then it feels easier rather than to stare at a fractional 2. So now, fairly easy, u prime over u for both terms. And number 49, of any questions, 47 or 48? Okay, 49 and 50. We can't avoid it. We have to use what? Quotient rule. Yeah, there's too many terms in the denominator. We can't split up. We have to go through quotient rule here. Okay, f prime g minus f g prime all over g squared. All right, try that. Try those. And no need to worry about cleaning up. Okay, we'll skip the last two problems, but if you can go back to page 10, I just wanted to do a little bit more revisiting from previous topics. But we'll do a formal quiz review starting Wednesday, but while we have some time here, page 10, number 7. Anytime you see a single messy natural log function, we always want to consider expansion. So you want to expand this all the way out so that the derivative can feel relatively easy. See if we can take advantage of some properties. Let's rewrite it with the radical in a different form. All this can be raised to what power? Good. Bring that 5/2 down, then you can take advantage of your quotient property. But most of our efforts is just cleaning up so that our calculus can be less steps. If we get all the way down to these two terms, then our derivative feels a lot cleaner. U prime over U, U prime over U. No need to do common denominators. Number 8. Look at the setup here. We do a little bit of expansion, right? You can bring that 2 down in front of the natural log of x. But this one we can't avoid it. We have to go through what rule here? Product rule, yeah. This for derivative, we have to see these are 2 distinct functions that cannot be merged. We have to go through product rule, but maybe I can do a little bit of just bring that 2 down. Then we can begin our product rule process. Let's go all the way down to number 12. Let's finish with reviewing derivative of inverse at a point. This is that whole process. We got to go through that chart, work our way around that chart. So let's look at number 12, page 10. All right. Anybody still need to look at 7 or 8? So the process here, we're trying to find the derivative of f inverse at 11. We can go through our chart here. Whatever we're looking for is always in the bottom right corner. We know that 11 is the x value of my inverse function, which must mean that 11 is the what of the function. Eleven is the what? Yeah. The y value. Yeah. So that's something we have to make sure that we understand that we're always going to start off. You're always going to be basically given the y value of the function you're working on. So this is let's set these equal to each other and see if we can figure out the x value that we need to use. So this is that's not something that we can solve. So we're going to bring everything over to one side. And we're going to go through a series of guess and check. So it should be an easy number to find. If you start with 0, if that doesn't work, then go to 1, then go to -1, and go back and forth. Integer values around 0, and eventually you'll find it. Okay, let's start with 0. Is 0 going to work? No. Okay. What about 1? 2 minus 3 minus 10, that doesn't quite get us 0. If I did -1, -2 plus 3 minus 10, that still doesn't equal to 0. What about 2? Okay, so if I try 2, 2 cubed is 8. 8 times 2 is 16. 16 minus 6 is 10. 10 minus 10 is 0. Okay, good. So after a couple of tries, we have our x value. So we can get the order pair relationship to show up. So now that we have our function f of x with more detail, the goal is if I can find f prime of 2, then this slope number is going to be related to with the answer I'm looking for. But before I can find f prime of 2, I first have to do what? Find f prime of x. Yep. So power rule. Plug in 2. So the slope at the F graph is 21. So the slope of the F inverse at its corresponding point, 11, must be what? 1/20. Don't change the sign, just flip your numerator and denominator. All right, any questions? So Wednesday, I'll give you guys a quiz review worksheets, and we'll start working through it. And our quiz over, I'm sorry. All right, Wednesday, we still have one more section to go over, but it'll be quick, and then we can begin our quiz review. We'll have the rest of the week to review, and then next quiz will be next Tuesday.